Okay. So what are we are into the third day. Thank you. Thank you, Mahesh sir. Good evening. Good evening to all. So it has been so good. What are the topics that we have seen on day one and day two? Can some of you put it onto the chat? On day one, we started with the concepts of, yeah, good evening, Venkateshwara Reddy sir. We started with the concept on big data. You remember day one, we started with the concept of big data. Yes, it is not, thank you, Harshini ma'am. It is not the size of data, but if you are not able to process your data, for example, we saw the maximum size of Google Drive. Okay, and then eventually, in order to process these things, we moved on into Hadoop. The solution is Hadoop. It initially was started for Yahoo, and then it is bought by Apache. And I've showed you the website of a Hadoop, Apache Hadoop, where you have got your binaries and sources. So we saw how to download binaries, and you've got different steps to start with the installation of Hadoop. All right, and then what and all we have seen on the first day, how the bigger organizations are having their own data center. Remember, what are the two data centers we have seen? The videos of it. Yes, Google. Thank you, Harshini ma'am. And what's the other one? It's the Facebook's data center, right? It's a Facebook's data center. So huge volume of data, how they're processing it. And you remember you saw a simple server, and it's all customized by Google or Hadoop. It's customized by Google or Hadoop. And then we moved on into the Hadoop framework. Yeah, in Google's data center also we saw Facebook's data center. We saw, it's 4 football grounds and just 10 people working on towards it, right? And all the data are replicated. If one data center fails, also immediately you get the data from the next data center, but you don't know from which data center are we getting it. All right. And then what are the major two components of Hadoop we saw on the day one? It's about HDFS and MapReduce. HDFS for storing and managing, and for processing and computing, we moved on into MapReduce component. So it works as a kind of master and slave. So we saw the master component of HDFS is name node, the slave component is data node, and for the MapReduce, it is job tracker as the master node and the task tracker as your slave node. Do you remember what example we saw yesterday to understand the concept of
recording in progress?
To understand, yes, thank you, Lohit. Okay, how the main node is the COE who distributes it to the faculty. So when it comes to faculty distributing it, the faculty, the invigilator becomes the master node and the students are the name node. So you know the date, time, the room number, the number of students, everything is told to you in advance. On the day of exam, you are the master node, you have everything on your brain, that is your name node. The students, they learn for the particular exams and come. Okay, actually we were seeing on Jan 20th they'll be having the semester, sometimes because due to some kind of lockdown, it may get postponed also, right? And then the student's brain is the data node, and then you map to each students which year they belong to, which kind of subject, what subject they are studying, and then you map to the faculty and the invigilator, and then you map to the there was some internet issue, it got cut, and again it is coming.
Okay. No issues, ma'am. No
Okay,
issues.
sorry for it. Never expected that to happen. Now I got connected through my mobile. Okay, mobile data. All of a sudden, the Wi-Fi router went off. Sorry for the inconvenience. Okay, and again I would start sharing my screen. Okay, and then we were seeing about what is the example. What is the example program? I showed you the demonstration of an inbuilt map, word count. You remember the map reduce algorithm? Yes, the map reduce. Yeah, the word count, inbuilt and user defined. And what was the last example that I showed you? What was the last example that I showed you? Uber. Okay, according, you have one more demonstration. If there is time, I will show you today. All right, and I showed you in Uber. Okay, in Uber, how many batches, how many active vehicles, how many active trips, which day they had most of the trips. All right, and how it is not only for word count and for different applications where you map and you have a job scheduling of mapping the task and reducing it. You will be able to work on with map reduce algorithms, right? Map reduce. So today we are going to these are the recaps of the first 2 days. Today we will be seeing the working of pig and hive. Okay, pig and hive. So you remember the framework that I showed you on day one? The entire, we have seen about HDFS. You remember the comments that we saw in HDFS, how to make directory and the location, the files on your HDFS is totally different from there onto your local system. It's totally different of that of your local system. All right, and then we saw the different commands, how to copy, how to move, how to create a directory, how to upload a file from local system to your Hadoop, and also you can retrieve get merge function from your Hadoop to your local system. All right, and then we saw what are the three parts in a map reduce algorithm that you write it on your own. You have a mapper function, you have a reducer function, and then you have a driver function, and then you have your driver function. So coming on to the framework, are you able to see my screen? I've shared my entire screen. Are you able to see my screen? Yes. Okay. Thank you. Thank you. Okay. So when you see here, and you can work with structured data and structured. We are not going into scoop and flume. We saw how it is stored, and you remember we saw about yarn. Yarn examples we have not seen demonstration. Maybe we'll start with pig and hive, and at the end of it, according to the time, I'll show you the demonstration. What is the full form of yarn? Yet another resource negotiator. What are the two components in yarn? Do you remember what are the two components in yarn? Anybody? Yeah, it splits the functionality. Yet another resource negotiator. Thank you. You remember when I start? Okay, just move to a terminal. Clear. Okay, can you see my terminal? All right. So I'm going to start my Hadoop. Start. Oh, yes, exactly, Meghla, ma'am. Okay, there are two components. Thank you, Harshini. Your answer is right. The resource manager and the node manager. The resource manager and your node manager. So whenever after you properly you install Hadoop, and when you start up Hadoop, these are the components that matter. If you do a mistake during the installation process, all right, eventually sometimes the name node doesn't open, sometimes the data node doesn't open, sometimes the node don't get a node manager, resource manager, but eventually you will not be able to run files using Hadoop ecosystem. All right, and you remember from which version of Hadoop yarn came into existence? Yarn came into existence after version 2 point. Okay, after version 2 point. All right, so it is taking time to getting a run. Okay, and So I don't know why things are very slow. Okay, can you see here? This is your entire Hadoop ecosystem. Okay, yes, the name node. So if you're going to take an unstructured data, you need to use the component of Flume. If you're going to use, I'm sorry, yeah. If you're going to use structured data, then you'll be using Scoop. Okay, using Scoop, you can drive in your data, and eventually, even before you want to work on all your data, should be there on the HDFS. I repeat it again: the files on an HDFS is totally different from your files onto your local system. It is nowhere connected to it. And then the next layer is yarn, and we have seen about MapReduce, how it works. So yesterday we saw about HDFS commands, the MapReduce, the inbuilt and the user defined functions, and yarn, right? The yarn we saw about it. So today we are going to see about these two components. Can you see here? It's a pig scripting component and the Hive component. Okay, Hive, it generally looks like a SQL. Okay, how do you write your SQL query? And you know, it's structured query language, and here the language that Hive uses is called as HQL. HQL, you can, if you're making a note, you can make a note of it. HQL, which stands for Hive Query Language. Okay, which stands for that. So there are different components. So we are going to see about Hive and Pig. All right. So these are the commands of yarn that we have not tried yesterday. Once so we told you once it runs, if I put JPS, Java Process Service, I'll be able to know, see, I've got my name node, I've got my data node. If my name node gets failure, I go to my secondary data node. Can you see the yarn component is your node manager and your resource manager? Remember this, the node manager and your resource manager. So which means if both are running, your here it is used for scheduler. Remember the capacity and the fair scheduler. We saw there are two schedulers it uses. Okay, the capacity and the fair scheduler. Application program manager, they accept the programs. Okay, what is the job to be done? Okay, and if I want to see the yarn version, okay. So these are some commands of yarn. Let me try to complete it before I move on. If I give yarn version, it will be the version of my Hadoop. Okay, and yeah, can you see the latest version? You remember I showed you on the website, it's 3.3.1, and it is compiled on 15/6/2021. So that's the latest version. Even the same answer I'll get if I give Hadoop version also. Okay, Hadoop version and yarn version. When I use these two commands, I get the same response. Okay, if I want to know what values that I need to work, yarn node hyphen help. Okay, so when you use this command yarn, yet another resource negotiator, the main components are the resource manager and the node manager. Okay, resource manager is the master component, node manager is the slave component. So if I give yarn node help, so here you will be able to see hyphen all works with a list of all nodes. Hyphen help I've given, hyphen list I can give, hyphen status, hyphen state. So if I'm going to give hyphen all, okay. So what are the valid nodes, whether it's new node or a running node? But for demonstration purpose, I'm just showing you a single node Hadoop cluster. Okay, the master is also the same and the slave is all the same. If you're going to install a multi-node Hadoop cluster, you will have different nodes, okay, where you'll be able to see it. And also you can find the states, okay. So if I'm going to give list, okay, hyphen list. Okay, now listen carefully. Hope you're able to see my screen. Okay, if I give yarn node hyphen list, so it will tell me, okay, it will tell me in which location, okay. So can you see here if I'm able to maximize it, maximize the terminal. All right, okay, okay. Can you see now? Which is there are totally only one node because it's a single node Hadoop cluster. And can you see the node ID here? Can you see this is my node ID? I can copy it 172.20.10.2 and this is the port number. Okay, so connecting to the resource manager. So where is your resource manager? 8032 localhost. All right, where is your resource manager works? And the node state, node HTTP address. So this is their running node. And how many containers number? See, till this it's one. Okay, this is the node state, and there will be a space, and number of running containers is 0. And I showed you yesterday. So localhost dot 9870 where you can see your name node and your data nodes. Okay, can you see now? Only I started it, so the version of it. All right, how many DFS and what's the journal? So where is your name node storage is being done? All right, and this is about the data node. And the next one, localhost uh, 8088. So 9870, you'll be able to see your HDFLs. You remember I told you in utilities, you go to the browse the file system, wherein you'll be able to see your files onto HDFS. Only if your file is on HDFS, then you can work with Yarn, then with your MapReduce, your Hive, your Kafka, Spark, anything onto that. So that you should understand very, very clearly. That you should understand. There's nowhere. So these are number of clusters. Can you see here new, saved, submitted, accepted, new? Because I have not given any jobs now. Okay, you can see the states of it. Okay, submitted application, the schedulers I told, right? 2 schedulers. Okay, the tools. Okay, you can see. All right, how once after you install it, you'll be able to see. But now I'm not running anything because, but you can see the nodes and the see default. Can you see the same ID that I've got it as your HTTP address? All right, the HTTP address. And this is the resource manager where it works. This is the node ID. So it's 160 GB and Jan 5th. So every time I run, it's a different ID that it will generate. So what are the applications, list of applications? There was no application. Can you see I told you about resource manager and the node manager? Can you see this is the resource manager? And okay. And the node manager. So node information, be able to see onto it. Okay, able to understand how yarn is being done and the configuration local phase. There are many things to dig onto it. I'm not going into deeper things because it's something new. I am just showing you what is available. Can you see here the scheduler is the capacity scheduler? Okay, so and then once I got this list, okay, I can also okay show you the status of it. I showed you the visual of it, so I have copied the note here. It is 172.20.10.2 colon, so this is the node ID and to the which port number it runs. And if I want to know the node status, yarn node hyphen status and the ID. Okay, yarn node hyphen status. Okay, so before you remember, I gave yarn underscore list. Okay, and then I give the ID, the node ID. So what I got it from the list. Here it's single node Hadoop cluster. So it will give me all the details of yarn. All right. I hope you're able to see my screen and able to get my audio too. Okay. So first, when you use yarn node, you have to find the list of nodes. See, now we are showing a demo with single node. Imagine how many nodes will be there in in Google, in Facebook, in LinkedIn, in Twitter. Can you see the node ID, the rack that specific node is running? Okay, there's no containers, the memory capacity, the virtual cores. All right, you're able to understand this. These are some of commands in yarn, okay, that we were not able to complete yesterday. Any doubts till now? Whether you're able to understand the concepts, at least yes, no, yes or no answers on chat. It's always a major challenge when we take sessions using webinar. There will be many people just switch it on and then they go and they come in the middle, okay, or at the end, okay. Yeah, it's very, very challenging because see, when I ask questions, only a few, yeah, yarn I showed you the demonstration also. Okay, yarn I showed you the demonstration how it works. Now coming into the major components of pig and hive. Yes, we are just starting Sai with what is pig and hive. Okay, you could have seen onto this structure. Do you remember seeing it on the framework? Okay, onto the framework. Do you all remember that we have seen? We have seen MapReduce, yarn, HDFS. Now we are moving on to pig and hive. Okay, pig and hive, pig for data analytics. Okay, so both pig and hive are the major components of Hadoop ecosystem. Okay, it's these two are the major components of Hadoop ecosystem. Basically, when you take hive, it is used for data analysis. In my company we have students, they come, research scholars, they come to work on with, and they have worked a lot and lot of works of using hive. Okay, like the recommendation system or the analyses. One student worked with the reviews, all right, and others other participant or research scholar, they worked with medical data. One worked with hotel reviews. Okay, so many things. Whatever, when you want to work with analysis, they use Hive and it can process huge volume of data. But we here, Hive uses only structured data. Keep it strong in your mind. Hive uses structured data. All right. So Hive, what it is used for? It is used for data analysis, to analyze your data from the reviews that you get. Okay, for scheduling or for analyzing how many people visited your shops or not, whether how many applications you have sent and how many you got admitted to your institutions. So many applications wherever you need an analysis. COVID data analysis, you remember, right? We are slowly again progressing towards a lockdown. Yes, you need not purchase on installation. This is all open free source tool. And you need to, yes, a Vignesh, but I don't know whether you're faculty or staff, sorry, student, and you need to have a step by step that you need to install it, and then only you can start working off with it. All right, it's totally an open source. No application to install. I showed you on the first day, right? Apache Hadoop, we need to download and we have to do a lot of configuration in certain files, and then only your Hadoop runs. All right, you need not pay for anything. It's a free software, but you should know how to work, how to install with that. We have not focused that onto this because the syllabus content given to me is this 5 days workshop. I'm handling it over it. Okay, if you want to learn, you can contact me. You could learn about it. Okay. Hive and here it uses like how you use SQL, which stands for Structured Query Language. Here it uses HQL, and this entire Hive is developed by Facebook. I told you, you remember when we saw data centers, these are customized servers, right? They are customized, and this particular component of Hive, that is, component of Hadoop, that's Hive, it is developed by Facebook. It's developed by Facebook. So when you take, because Facebook is lot to analyze, right? You get a throwback photos last year, this time what are the photos we updated. It is not by any humans, it is all automated programming, right? So for data analysis, how many people liked, how many people commented, when I post something, how many people is reachable on a paid something. So it's all analytics. Okay, so this component was very, very widely used tool developed by Facebook, and it is used by Facebook. It's a data warehouse infrastructure. So what is the language it uses? HQL. Okay, which stands for Hive Query Language, which stands for Hive Query Language. So ETL. Okay, this you would have learned in normal databases also. ETL, it stands for extract, transform, and load the data. Extract, transform, and load the data. All right. So in Hive, we can use our customized mapper and reducer. Lot of even map reducing is worked by Facebook's, right? So they have got their own customized. How do you map? How do you reduce it? For data analytics and reporting related, if you want to see, that's what it gives. Lot of reports, right? When you want to develop a reporting softwares or you want analytics softwares, the most preferred component of Hadoop is Hive. So able to understand. Hive uses structured language. That is one thing you have to understand. It's for data analysis. Second point you need to understand. And the third, it uses HQL, which stands for Hive Query Language. Okay. Now coming on to pick the next component. Okay, the next I'll just giving the introduction and then about the comparisons, where you should use pick, where you should use Hive. You cannot use it on all the places. Okay, in 2006 this pick was developed by Yahoo. Who developed Hive? Can I have the answers on chat, please? Yes, ma'am. They have the recording, so you can get it. And also, I'm streaming the session on YouTube Live. You can check it on to my channel, Doreen Robin. You'll be able to get it. Okay. Yes. Okay. Who developed Hive? There are the 38, 40, 40, around 40 people. Who developed Hive? I will send you. Even yesterday I showed my contact number. You would be able to get it. Okay. Last slide I told you. Let me get any one of you are giving the answer. Who developed? Yes, rightly said Lohit. Hive was developed by Facebook. Okay. Now when you take Pig, okay, Pig is developed by Yahoo. And you remember I told before the Hadoop was developed by Yahoo, and then they gave it over to Apache. Okay, in 2006 it was developed by Yahoo, basically to reduce the complexity of MapReduce. Okay, the MapReduce programs complexities. Okay, when you use, we don't have much time. If we have time, I can show you how MapReduce is done using Python. You've seen so many lines of code yesterday on Java. Just with 10 or 5 lines of code, you can do it on MapReduce. All right. Yeah, Pig, it is developed by Yahoo. Okay. So for big data is a kind of extract, transform, and load, and it can handle huge volumes of data. When you take Pig, it can handle huge volumes of data. So what is the language Hive uses? HQL, do you remember? And here Pig uses Pig Latin scripts. Okay, it uses Pig Latin scripts. Understand? So basically, this is for more people on programming, for security, for encrypted data, for medical data in abroad countries, where the data are to be stored safely without hacking. Those kind of data are stored using Pig. Okay. And most of us SQL, so HQL would be easy. Those programmers, those are familiar with scripting, right? Like JavaScript and other scripting languages, they will be working with Pig. Okay. When those are working with query languages, all right, they use Hive. Okay, people working with query languages, they use Hive. All right. So coming on to that, also to store the data, there is no need to create a schema. Here even unstructured values could be used. Okay, so pig compiler translates pig Latin into sequences of MapReduce. Okay, sound door. Okay. நீங்க உள்ள வாங்க. Okay, pig compiler translates pig Latin into sequence of MapReduce program. So in order to reduce the complexity, of MapReduce only, Facebook also used Hive, but it uses HQL language. It's very, very easier. Okay, which is very, very easier to work on with that. Okay, but when you want a scripting language, those are familiar with scripting and more programming, all right, and you'll be able to work on with that. Okay, you'll be able to work on with pig. So pig has a procedural data flow language. Pig has a procedural data flow language which stands for pig Latin. Okay, Hive uses a declarative language. So remember, pig uses a procedural data flow language. I will show you the demo of it or the snippets of it. Okay, and then Hive is mainly used for creating reports. I told, right, for data analysis, for reports, we use Hive. For pig, when it is used for pig Latin, it is used for data flow language. It's for a data flow language. Mainly, pig is used by programmers who are strong programmings, and Hive maybe it's used only for data analysis. And more security is available in pig or Hive. Which has more security, pig or Hive? It is the data is more secure than pig and is used for electronic health records to be stored. All right. Pig generally it is used by researchers and programmers, the pig scripting. Hive operates on the server side of any clusters. Okay, it's like a kind of database. You have huge volume of data, but what is that? You need to remember whatever is the data, it should be onto your HDFS to be processed by pig or Hive. Is it clear till now? Yes, you can type your answers yes on the chat. No, you can type no on the chat till what you have seen. Yes, thank you, Sai. Thank you, Surya ma'am. Only few are responding. I don't know how many of you are truly listening to it. All right, thank you, Lohit. Okay, and the big supports, what is the file format? Avro file format it supports, but Hive does not support Avro file format. Okay, because we are all new into pig and Hive, sometimes we get confused, why pig, why Hive, that's what. So Apache, Hive, to recap the comparison between and these two, Hive uses a Hive uses a declarative language called HQL. Pig uses a procedure language called as pig Latin. It's a scripting language. It is a query language. Okay, to find the difference, it's a query language, a scripting. It is used by data analysis. Hive is used, so you should know for what kind of application, what is the problem statement that you're going to develop using Hadoop. You should be very clear of using what component. For researchers and programmers, they use pig Latin script. Okay, it uses structured data. Pig, you can use structured data, and also it provides semi-structured data, which is not available for Hive. All right. And when you take Hive, Hive is on the server side and pig operates on the client side of a cluster. Okay. On the server side of the component, you have Hive. Onto the client side, you have your pig. ETL, okay, it is to extract, transform, and load. Okay, it's helpful for extract, transform, load. Pig itself is a ETL tool for big data. Pig itself is a ETL tool. ETL, extract, transform, and load. All right, and then when you take Apache Hive, it does not support Avro file format. All right, but here, sorry, Hive doesn't support, but Pig supports Avro file format. Hive is developed by Facebook and Pig is developed by Yahoo. It supports partitioning. I'll show you an example. I'll not be able to run and show, but I will show you the scripts. Okay, I'll show you the scripts. All right. And a pig does not support Pig does not support partitioning. Pig does not support partitioning. And loading speed, Hive is very quick, and it cannot it can execute fast, but it cannot load quickly. But Pig can load quickly, and also it can execute faster. It can load and also execute faster, but Hive can execute faster but cannot load quickly. So the user, it supports user defined functions, Hive, but it's very hard to debug. Pig, it's very easy to write your user defined function. Pig is very easy to write your user defined functions. All right. So where we use Hive basically for data analytics. Pig is used for scripting language, okay, for researchers, because you can write your own user defined functions, whereas in Hive you can take up your user defined. You can use what are the functions that is inbuilt, but it's little very hard to write your user defined functions in Hive. So generally it's used for analytics of historical data, okay. It also uses ETL, and it supports only for structure. If you have a data set that is structured, then we go in for Hive. But one thing is that it does not support real-time analytics. So if you take Uber and Ola, you need real-time analytics, right? How it has been done. And but HBase, it's an alternative. We are not dealing with HBase, so when we have time, maybe sometime. HBase, it supports real-time analytics, okay. So when after you analyze, you can visualize, you can use reports. But Hive is comparatively slower than Pig, but Pig can be used only by people who are programmers, but Hive can be used by simple programmers also. All right. While you know your scripting language and you're very well programmer, you can directly go on using Pig. Okay, you can use on Pig data, especially for all the data loaded. You don't want to create a schema for it. Okay, since you have many SQL related functions and Cobra, it does not support Avro file format. Pig is faster than Hive. Pig is faster than Hive. Okay, so you're able to understand the Pig and Hive general concepts and the comparisons, yes or no? Yeah, I'm getting response only from 4 people. What about others? Okay, thank you. Some of your silent listeners. Okay, thank you. All right. Okay, so what are the types of data inside Pig? Okay, you remember I told you Pig supports both structured data set and unstructured data set. Okay, atom, when you take first data type is atom. It's a very simple data value stored as a string, but it can be either a string or a number. Okay, either a string or a number. That's the very first data type of Pig. Okay, atom, atom, atom. The advanced data type is called tuple. Okay, here you have a sequence of fields. Okay, each piece of field is a field of any type, an atom, a tuple, or a bag. Okay, so and a bag, when you take the next level, it's a set of tuple. Okay, and also sometimes you can refer it as a relationship. Also, it's a kind of table. Okay, I told you Pig, it supports both structured and also semi-structured. Map, if you take the fourth data type, okay, maps, they are string literals to value, key value plus. Here you have the concept of hashing. Do you remember learning about hashing? In data structures, many places. Have you walked? Do you remember the concept of hashing? Yes means type yes, no means type no. Hashing function. Yes, definitely. As computer professionals, we should have learned about hashing function. So what are the 4 data types? Pig has got atom, that's very basic, tuples, bags, and a set of tuples. Bags is the next level. Can you see? I'll show you. Okay, say for example, these are the 4 basic data types models that it allows. Okay, that it allows atoms, tuples, the next level is bag, and the 4th level is map. Okay, this is an example, a b. Okay, it could be a string or it could be a number. So what are the types? It could be int, it could be long, it could be double, or a string. Okay, it could be double or a string. When you take tuple, it can be of any data. Abhi, comma 14, maybe you can think of the age. So the next level, a sequence of fields. That each field could be of different data types. Okay, that is what we say to be a tuple. When you take bags, bag means you can take a collection of tuple, and each tuple can have different number of attributes. Okay. Okay. Uh, each tuple can have, see here you have just one, and onto Manu you have got one, and inside after Manu you have got a subtuple also. Bag is a collection of tuple and each can have varying structure, and also you can have duplicates inside bags. Then I told you map, it's like an associative array where it uses the concept of hash, but the value can be, key must be a character array. So it works with key value pairs. Okay, when you take maps, it works with key value pairs, but the key should be of a character array, and it uses the concept of hashing. Okay, are you able to understand the 4 data types? Okay, so I told you when you want to work, your data set will be into HDFS. Okay, and then for the map, so you write your pig Latin script. Okay, you write your pig Latin script. It can go into a grunt shell and pig server. Okay, this is your main running part of your Apache pig. It parses, because you remember atom, tuple, bag and map. So it parses, then it optimizes, it compiles, and it does the execution, computes a map reduce, and it gets stored into your HDFS. This is your working of your pig Latin script. This is the working of your pig Latin script. Okay, what are the functionalities that pig supports? We saw the 4 data types. What are the functionality here? It supports grouping. Okay, join operation on data types, your databases you should have done, filtering and aggregation. So, and also the most widely used needed thing of pig is scholars. You can write very easily your user defined function. Okay, so it is used for diagnostic operators, grouping and joining, for combining, splitting, for filtering and sorting. So when you have operations of this type for your research, then you can go in for pig. It's a client application. Remember, Hive is a server application, pig is a client application. It parses, it optimizes, and it executes, submits your map reduce job to the cluster. So that's the same thing I showed you on this: parses, optimizes, compile. So these are the major 3 steps, and then it goes into map reduce. Okay, so what are the 2 modes that you can run pig? Okay, you can run it as a local mode where all the files are running using a local host and file system, but the second one is more predominantly used because we are going to work with the Hadoop cluster. All the files are installed and it runs on a Hadoop cluster and your HDFS. So we saw about how the files are there into your HDFS, and then so this is how pig grunt shell. By using pig grunt shell, this is an interactive shell. Okay, and pig, this is a batch mode of it. id.pig, the data type is pig and the parameters. Okay, you have to, how a pig is generally, pig scripts are generally organized. You have a loading data, you have to read, then you transform it, you store it and dump the values. These are the 4 steps. You load, you transform, you store the values and you dump it. So this is how you load, you transform, you group it, and then you store it and dump it. Can you see here? The same word called loads, changes, dot as line dot character array for each input line, because I'm storing into it, generate flatten, I'm tokenizing as word, then I'm filtering by word matches, then I'm grouping the filtered words, then for each word group generate count, I'm using the function count, and as count I'm group as words, then order the word counts by count size descending, and then I'm storing the ordered words into a file. Here you execute your pig scripts. This is how you write your pig scripts. Okay, pig -h is your help, and grunt, you get your grunt shell. So I showed you, right? When you give, when you type pig, you get a grunt and a greater symbol. This is your grunt shell. Okay, this is your grunt shell. And also in grunt, present working directory, puts, get, copy, list, make directory, remove, move directory, everything. Pig supports all your HDFS commands, whatever we have seen before also. Pig is pig. There is nothing kind of expansion. Okay, it's a pig Latin script. Okay, pig Latin script are grouped together in a file. You have an inline comments and your block comments. Can you see even in the example I showed you an inline comment, this hyphen, right? This is your inline commenting statement. Okay. And then if I want a block comments, asterisk, slash, asterisk, and asterisk slash. So these are the different data types that it also allows. Complex data types is what atom, tuple, bag, and map. Okay. These are other things which you generally know about. Okay. So it can be, generally we use dump. Okay. We use dump to store it. So loading the data sets. So I'm taking a structured data, employee.text, loading as ID, name, and salary, and using pick storage as ID, name, and salary. So you have new bags, each bag has multiple atoms. All right, each bag is immutable because it's a tuple. Okay, and then you store it into the process text and you dump it. These are the load, transform, store, and dump. These are the 4 things that you use. So these are the different relation operators that you can use. I'm not going into deep. I'll just move into Hive now. Okay. When you take Hive, it is developed by Facebook, all right, and it uses HQL. Okay, and it uses HQL, which is SQL like query language. Okay, how many of you have experienced SQL? How many of you have worked with SQL language? Yes, no? Only 3 to 4. The same people only I'm getting the response. I don't know what about the other 30 plus. Okay. You know, right? So you need, I have seen but not researched. Okay. Okay, Sai. Okay. It is exactly like SQL, but your files will be on your Hadoop system. Okay. Yeah, used in DBMS lab. Yes. Okay, and it generates MapReduce both. Even there, pick, you load it, you compile it, and then you execute it onto a MapReduce. Here also, both are done to ease the concept of MapReduce functionalities, both Pig and Hive. So when those people who are into more programming, they go into Pig, and others they come into Hive. It generates MapReduce jobs. It enables data summarization. Remember, it's for analyzing huge volume of data. It's used for batch processing. Okay, it's not an OLTP or real-time system. Okay, here it's an analysis. Okay, analysis. So you have separate tables. The tables, you create tables and you have schemas for it. And here it supports partitioning, but Pig does not support partitioning. Okay, and here you can have a something concept called buckets, different buckets. We have run so many programs using buckets and join operators. So how you use your SQL, like select asterisk from which, where, everything. The joining tables, the inner join, the outer join. Okay, and group by functions and storing the query into another table. And also you can store your result onto HDFS and you can extract from it also. Create, drop, alter. So these are the different data types. Tiny int, small int, big int, okay, float, double, struct. These are the complex. So you can define a structure. It's a collection of element. If S is of type struct, A int, B int, S dot A returns A. Map, the same thing, key value pass, M groups returns GID, array list. Okay. So HQL supports EQ join, outer joins, left semi joins also. It is only a shell for MapReduce. Okay, you have an having class. Okay, missing large part of full SQL. You don't have having, you have, right, one clause when you use in SQL. Correlated subqueries, these are not available in HQL. So it also stores the data as a metadata. It stores the data as a metadata and uses Apache Derby. Okay, Apache Derby, where you embed in-process metastores for in-process database. Local for each Hive client, the metabus, and also you can use remote. So the 3 configuration, what we have done, and we don't have time to show the demonstration. All right, and what I've done is for the local one. Okay, for the local one, Hive tables or user Hive, or which location you have stored your Hive, and the tables are subdirectories, partitions are subdirectories of tables. Okay, external tables also are supported in Hive. External tables are also supported in Hive. Metadata is a part of data of it. All right. the entire data, you make it as a metadata. So you refer it, it will be in different places on HDFS and you be able to take it. The actual data is stored in flat files. Okay, actual data is stored. So when you take Hive as a schema on read, okay, it has got greater flexibility. This is how you create. I'll go into the syntax of Hive as we have got just 1 or 2 minutes more. Create table. You can give a table name. Column, what is the data type? Column 2, what is the data type? Column 3, what is the data type? And column 4. Row format, delimited. So how it is delimited? By fields designated by comma and stored as format type. This is the syntax of creating a table. So this is an example of creating a very, very simple table. Okay, very, very almost, yeah, it's almost similar to SQL. Some of the higher functions of SQL, you will not be able to use it in Hive. All right, and view time int, user ID big int, page URL, referral URL, IP, string command. So this is a command statement of your table. So it is an IP address of the user. Row formatted, it's \t, which means every values you're going to give \t for every values 1, 2, and 3, and 4, and it is stored as a text file. It is stored as a text file. This is a more complex one, subordinates, detection. I'm not going much into it. Okay. And I can also create an external table. I told you, right? Local, external, and remote table. Okay. Same thing. Create, you can load the files into the Hive directory. You can drop the metadata and the data to be deleted. Okay. External table, you know files to be moved, only metadata to be deleted. Okay. So it provides partitioning. Bucketing is one concept. So you have different buckets, puts your data into it, process it, and you can get back your data. Okay. And so I told you, right, partitioning, it can make some queries very fast, and it is used by partition by clause is used when you create a table itself. Okay, so partitioning clause is used, shows partitioning of your table. So when you come into bucketing, it speeds up, but it is clustered by. So when I'm use partitioning, when I create the table itself, I'll use the keyword as partition by. When I'm going to use bucketing function, I'll be using now I'll not be able to show. Already it is time. Okay, maybe tomorrow also we've got NoSQL and Cassandra and MongoDB. Let's see. Okay, so it uses cluster data, and so show tables, show page views, describe. This is how you can load on your local path into the table. So if you have got your entire data set, okay, you can just load data local in path from which CSV or text file you can overwrite into tables and partition by how you want to partition. This is for partitioning. Okay, and so these are the other relation operators that you can work on with. I'm not going into the advanced part of it. So today, what we have seen, we started with yarn, right? We started with yarn, some demonstration of yarn node help, yarn node list, and then from the list I showed you the status of one node because we have installed single node Hadoop cluster. And then we started with the difference of Pig and Hive. Who developed Pig? Who developed Hive? Okay, Pig is developed by, yes, Yahoo. Hive by Facebook. And which is used for data analytics? Which tool is used for data analytics, Pig or Hive? Hive, exactly said. And Pig is used by researchers and programmers. It uses Pig's Latin script, and therein you'll be able to easily write your user-defined functions. But in Hive, you can process like in SQL, but writing user-defined function is very, very complex. And we showed you what are the different methods that you'll be able to work on with that. All right. So over to the organizers. Hope you should have understood some concepts about Pig and Hive.
Thank you, ma'am. It was such a wonderful session about Pig and Hive from the scratch. Thank you so much, ma'am. Thank you. And participants, if you have any queries, you can raise it now. Okay. Okay. Thank you all participants. Just wait for 1 more minute to take the snapshot. Kindly switch on your videos. Kindly switch on your videos. Kindly switch on your videos. Thank you all. Thank you very much. And let's meet tomorrow. Thank you. Thank you.
Thank you, ma'am.